associate professor of engineering education at the School of Engineering Education. I help host these seminars. I'm going to turn things over to our official MC here in just a second. If you are interested in engineering education type research talks, we have a whole bunch of them at this time, in this place, every week, with a schedule up at the front. Please grab one before you leave. That's all I'm going to say. I'm going to turn things over to our Associate Dean for Faculty Affairs. So,
good afternoon, everybody. Welcome. I know this is part of the seminar series for uni, but it's also in the college what we call Celebration of Faculty Careers Colloquium. And so I want to welcome you to the next one in our series. Just to very briefly summarize, this is a process that was started a little bit less than 2 years ago in the college to give the opportunity to senior faculty, specifically full professor that have been in the full professor rank for more than 7 years, to come and share with their colleagues and students and staff their experience of being a faculty member at Purdue, and share their perspectives, with everybody, so that everybody can actually benefit from their experience. And they're supposed to do this once every 7 years after that. And then they get a chance to meet with the dean and their department head to plan for the future. And so today, we're very privileged to have a very special faculty member. And as you all know, I'm not sure if he needs, I'm going to make it very brief because I know you all know him very well. Professor Phil Wankat is the Clifton and Lovell Professor, Distinguished Professor of Chemical Engineering and Engineering Education. And he has been on the faculty since 1970. And so I know that he has a lot of treasures to share with us. And so I'm looking forward to his talk. Phil.
Thank you. Well, I'm happy to tell Claude that I have been in rank for 37 years, so it's okay for me to give this presentation. I never gave a presentation when I was hired. I was hired without a seminar, and I think this is the first time I've given a seminar to engineering at Purdue. So, which is a little hard to believe, but it's honestly true. Okay, I'm going to talk about my career. First of all, what's more important than career, why I'm proud to teach engineering people, the official career, which is things that I've done, and lots of stories, I hope. Okay, it starts with my parents. My mother was a nurse, my father was a chemist. The only advice I ever got on careers was from my father, which was, be a chemical engineer, don't be a chemist. And I followed that advice. There I am as an assistant professor. We all go through that. Probably the best decision I made was getting married in 1980. And because I think family is important. This is a staged picture. And the chemical engineers in the audience who've been here for a while may know who the young lady is that is right there. Since it was 1984, she obviously is no longer young. But neither am I. So, okay, these are my children, Charlie and Jenny. And they get older. I got older. And you may not have noticed, but in the first photo, my beard was nice and brown, and it isn't any longer. There's a current picture. And if I can do this properly, yeah. What I have on here are some things that are important. This is a medallion that Chuck gave us. He is serving in the Navy at Guantanamo Bay. This is a It's actually a caterpillar that my daughter made for me. This is my safety blanket for the talk. And then on my finger is the ring that Dot gave me that I wear all the time. And there I am recently, and there's Dot going through passport control in Turkey when she was visiting a friend of hers. And I want to talk why I'm proud to be in engineering, and if I can get into what I want. Let's get rid of this.
I am, and ever will be, a White Sox pocket protector nerdy engineer. Born under the second law of thermodynamics, seeped in the steam tables, in love with free body diagrams, transformed by Laplace and propelled by compressible flow. As an engineer, I take a substantial amount of pride in the accomplishments of my profession. Science is about what is, engineering is about what can be. Engineers' entire existence is dedicated to doing things better and more efficiently. It is a profession which leaves its imprint on our society in countless ways. A century ago, the world really needed improvements in quality of life, health, mobility, and living standards. At that time, life was a constant struggle. The 20th was a century often punctuated with the terror of war, darkened with societal struggles to overcome injustice. But the 20th was also the first century in which technology enabled the tenets and the images of those traumas to reach across the world and touch people in ways that were previously unimagined. Engineering helped create a world in which no injustice could be hidden. Many will look back to see how we have changed and what we have accomplished. The future's a bit foggy, but it's not unreasonable to suggest that the 21st century will enjoy a rate of progress not unlike the 20th. It's something to hope for.
There we go.
Back up to,
Yeah.
oh gosh.
Yeah, I get.
You'll figure it out. The reprise.
Okay. I thought that Neil Armstrong said some of those things much better than I could. I just want to talk a little bit about the career, and I've done this in color-coded, that the black is the official statement of what I was supposedly doing, the green is what happens in my technical career, and then the, I guess purple would be the color, is the what happened in the educational aspects. So I graduated from Purdue, I went to Princeton, I got hired back as an assistant professor, and I had a startup package. The people who started the semester before me were actually jealous because I had a better startup package than they did. I got $1,000. And they offered to let me teach in the summer so I'd get some summer salary. Okay? Compare that to current startup packages, and they're a little different. But I will say later that there were lots of advantages to starting then. Okay, I then I taught my first course. The teaching evaluations were mediocre. That upset me drastically. I found then a course on educational psychology for college teaching, which is still available at Purdue. It was one of the pioneering courses in the entire country on how to teach college. So I took Psych 695. And suddenly what happens is you find out that there are numerous different teaching methods that you've never seen. And sometimes they work better than lecturing. So I took that, and that was in 1972. 2 years later, I won a teaching award. It turns out that's not unusual for people to train them in how to teach, and then a couple years later, they win a teaching award. I had my first Purdue publications in 1972 and $16,000 from an NSF grant. And again, you got to compare that to now, but that $16,000 probably went pretty far compared to what they do now. I graduated my first master's student, and in '73 I had my first educational presentation. FIE was at Purdue that semester. I got promoted in 1974. Now, that sounds quick, but it was average. The rate at that time was about 4 years or 5 years to be promoted. So I got promoted in 4.5, which is as close to average as you can get. I applied to get a master's in education at Purdue. I was turned down. And then I went on sabbatical. And when I came back, I should say that I tried to write a monograph, but I quit. And the reason was I decided I didn't know enough, which sounds unusual, but I had only been doing separations research since 1971. I did my PhD on hydrodynamic stability analysis and then switched, which of course is not the advice we give to new faculty now. So I then lined up my ducks in a row and got the department head, Lowell Koppel, and the dean, Dean Hancock, to back my desire to get a master's in education. And actually the provost was trapped because the provost could not say that taking education courses wouldn't improve teaching. Politically, he can't say that. And he could not say that teaching was not important at Purdue. So he approved it, and I have the letter, and the letter says, this is not a precedent. Of course, now we encourage people to do this. The university has done a 180-degree flip on it. Okay, I decided it was time to, I earned the master's, and everybody turned on my textbook that was half written. And if you want a real downer, send your textbook to every major publisher and have them all turn it down. Okay, and they said, we don't need another separations textbook. I disagreed, but I didn't control it. So I earned a master's degree and decided it was time to give back. Ended up teaching the course. I offered to teach it as an overload. I had to sit and argue for about half an hour with the department head, Ron Andres, to let me teach the course as an overload. And then he suggested, well, why don't you work with Frank Orovitz, who's just been hired in a department as a communications specialist. And my reaction, which I didn't say, was, well, I've just argued with the department head for half an hour. I don't know Frank Orovitz, but I'm not going to keep arguing with the department head. So I said yes. Well, it worked out, and Frank and I wrote some 75 papers in a book together. So it turned out to be a very nice thing that Ron did for me there. So I went on sabbatical, and I wrote the research monograph that I tried to write earlier. I now figured that I knew enough, having done separations for over 10 years. And when I came back, I found a publisher, a secondary publisher. I didn't go back to the big boys. And I had published the monograph. In 1987, Dean Yang actually read the CVs that are collected by the dean's office. Now, I don't know if you read the CVs that you collect, but Dean Yang actually read them. And he noticed in my CV that I had earned a master's degree in education. And he thought anybody crazy enough to do that deserved the prize of being in charge of freshman engineering. And they were doing a search committee, which the dean was not on, but he kind of controlled from behind the scenes. So I became head of freshman engineering. And at that time, my text was almost done, so I finished it when I went over to freshman engineering. And to make a long story short, it was published by Elsevier, who then sold all their books, and Prentice Hall picked it up, one of the companies that had refused me to start with. Okay, I did some editing. I wrote a graduate text. Frank and I published Teaching Engineering, which the interesting thing is that didn't make any money, but it had a lot of impact. While it was with McGraw-Hill, Frank and I got 25 cents per copy each. Okay, so write a textbook. A book is not necessarily the way to get rich, but if it goes over well, it will get you well known. And in 1995, I became the associate editor of Chemical Engineering Education, working with Tim Anderson in Florida. In 1986, we started writing a regular column. Now, how did I get the offer to write a regular column in Prism? Well, I offered to write a last word. They have a column at the last page of Prism, which is called Last Word. And they said, sure. And they said, why don't you give it to us in 5 months? I said, sure. And then about a month later, they said, can you get it to us in 2 weeks? The person who was supposed to publish in this next issue told us he's not going to do it. So I did. And then they came back to me and said, how would you like to write a regular column? Because they figured if I could do that in 2 weeks, I was reliable. And it turns out that's probably the number one thing that publishers want. They want you to be reliable. Turns out that half of the textbooks that our contracts are written for are never published because the authors never get them in. You got to think about that they want reliability. So we did that for 8.5 years. And I knew I would do that sometime during the talk. Somewhere back here, yeah. Okay. And then in 1998, Rex and some of the other faculty went through the effort of getting me to be a distinguished professor. In 2000, Dave Kessler stepped down from as being head of the division of interdisciplinary engineering. And so I did that half-time, and I did chemical engineering half-time. And wrote another book. Then I became the interim associate dean for 1 semester. Now, I'm an introvert. And that job is a job where you spend all your time talking to people, which I'm sure is what Claude does. Claude can't be an introvert because he wouldn't have lasted this long. I would go home every night, turn on the computer, and play Spider Solitaire for an hour or an hour and a half. When I stopped that job, I stopped playing Spider Solitaire. I just cold turkey. It was easy. I did one thing that I'm proud of during that course. Oh, I keep hitting the wrong button. Which is that okay. As the interim associate dean, we had a committee to set up E&E. And E&E was going to be set up with no undergraduate program. And I realized that I had a problem in the interdisciplinary program that we could not become ABET accredited because we had no faculty. It was me half-time. That was the entire faculty. And ABET didn't had outcomes, but I didn't think that the outcomes would stretch that much. So I figured if we merged IDE, E&E would have an undergraduate program, and that IDE would be able to get ABET accredited. So I suggested to the dean not that she ordered the merger, but that she open up the charge to the committee so that a merger would be within the charge if the committee thought it was the best thing to do. And the committee, with the exception of one person who had some doubts, agreed. And the person who had doubts was Kamiar Hagigi. Now, why would Kamiar have doubts? Well, I talked to him, and it turned out that Kamiar thought that this was going to be a coup and that he was going to be kicked out. And once I convinced him that that wasn't happening, that he was going to be department head and I was just going to run the undergraduate program, he thought it was a wonderful idea. Okay. And so, of course, we did that and became part of E&E in 2004. And so I directed the undergraduate programs until last year, at which time I became a professor again. Okay, so I've done multiple editions of the undergraduate text. The only problem is that I sat on this text for 18, 19 years, and what I did is you watch your adoptions go up and they peak and then they start coming down because you don't renew it, and the competition does. So after 19 years, I wrote the second edition, and it might as well have been a new book. In 2011, Christine and I wrote a pictorial history for the 100th anniversary of chemical engineering. We did a third edition. You note the time frame between the second and third was nowhere close to 18 years, okay? Well, I passed my own record. In 2015, yesterday, I got the second edition of Teaching Engineering, 22 years after the first edition came out. So it takes a little bit of time. And there's the second edition of Teaching Engineering. Parts of it were obsolete, but most of it held up reasonably well, that it was really quite decent. And Susan Montgomery and Michael Louie, I owe a real debt to because they both reviewed it and gave me enormously helpful comments. And we're going to sell it for $10 to students. So this is meant to be available to people quite cheap. Okay, so I am now in phase retirement. I'm halfway through phase retirement, and I have my last PhD student should graduate in March. I plan on writing a fourth edition of the book. Actually, I'm started working on the fourth edition of the book because I'm teaching the course. And if you look at this and consider current advice for new faculty, I've done everything wrong. Okay? I didn't stay in the same field that I started in research-wise. I switched when I was an assistant professor. And I went into administration, but I kept doing my research. And then I got out of administration. And I spent a lot of time on teaching things. So I think if you do what you love, it's more likely to work. Worked with lots of people. The person I worked with most was Frank Orovitz, but lots and lots of people. And I didn't list all the grad students because it would have filled up another page. So. Okay, changes in the profession. Now and 50 years ago, talk about grants, professorial duties, and how professors spend their time. And then I'm going to finish with improving engineering education. Well, there's a big difference between now and 50 years ago. Currently, people are much better trained in research. They've all had postdocs. They have a detailed research plan. Literally, we didn't know what a research plan was. The research currently is often not directly connected to practice and not connected to undergraduate courses, well, whereas our research often was connected. Startup packages, I already told you mine, which people would laugh at if that was what they were offered now. Currently, people often will have training in how to teach. We didn't have training in how to teach, but it was more likely that we had a calling in teaching. There's little interest nowadays in writing textbooks. When I came back to Purdue, Purdue had the history of publishing a lot of first-class textbooks in engineering. And I wanted to be part of that history, so I wrote textbooks. I think the biggest thing is that now the only path to success is technical research. We believe there were many paths to success. You didn't have to follow a single path. There was a considerable help in grant writing, and really there wasn't much help, but we'd be invited to work with the research team, and they knew something about how to write grants. If you can't read this, it says, I should warn you that I'll only turn into an assistant professor. I always liked the frog and princess jokes. Here's the grant cycle. I honestly thought that it worked like this, okay? You wrote the grants and then you did the research after you got the money. And of course, it really doesn't work like that at all. You do the research first and then you write the grant because you can prove that it works and therefore you'll get the grant and then you can do it to do the next round of research. The duties of professors have changed. There's less teaching, but we teach more undergraduates. Doesn't make sense, but the classes have gotten bigger, so you can teach less and teach more at the same time. Advising undergraduates has been relegated to professional advisors to a large extent. People manage research groups. When we started, we worked with the students. We didn't manage the research group. The professors are much more entrepreneurial. They have to be. People worry about protecting intellectual property and let somebody else write the textbooks. And as I commented, that one of the things I wanted to do as a professor was write textbooks, which was part of the history of Purdue. Lots of schools now have permanent instructors, people with PhDs who are spending time on doing teaching and not doing research. And there's also professors of practice, okay, like Jeff Sorolla and Mary Palat. And I think this is wonderful because they bring in an industrial flavor, and most of our students, undergraduates, go into industry. Most of the other faculty don't have experience in teaching. And one of the strange things is that there are more professors in E&E who have industrial experience percentage-wise than I think in any other department of engineering at Purdue. That's true, because a lot of people did industrial experience and then after that decided that they really wanted to be in education. Okay, how do professors spend their time? This is data. The data here is for all fields, not just engineering. And of course, don't tell me what to do is what all professors would like to do on their time. And I thought this was particularly cute that they have service. Okay, ABET. I'm going to give a backhanded compliment. They fixed the problem they caused with counting P's. Well, okay, so that's nice. They fixed one problem. And real praise is that I think ABET 2000 has improved engineering education, particularly in professional aspects, because they have made people focus on it, and people weren't focusing on it before, so it improved. They need to work on the variability of their visitors. ABET knows that, but you don't see results. And they have the potential, they have the power to force improvements. Now, why haven't we improved engineering education? We have lots of data. We know how to teach better. And if you want to teach better, the last thing you would do is have somebody like me standing up here lecturing at you for the whole time, all right? But I think the problems are, one is that there are silos. Chemical engineers don't read the literature, say, in electrical engineering. And if NSF has put a big project into the double E's and they have developed a great new technique, we never hear about it because we don't open the IEEE transactions on education. And that's one problem, which I showed in some fairly small scale studies, and Krishna Madhavan showed in a huge study that it was true. Second, professors are unaware of methods because most professors have had no pedagogical training. And I have a quote from SPE, was the precursor of ASE. Over 100 years ago, people were talking about we ought to train professors. And it hasn't happened. Third is the reward system. That's everybody's excuse. It's not really as important as people use it. I think they use it as an excuse because the reward system is this big thing up there that we can't possibly change by ourselves. The other thing is quoting Pogo, we've met the enemy and he is us. We, the professors, are the reward system to a large extent. And we have a little control if we wanted to do it. Okay, so it's tough to make predictions. I'm going to tell you why I'm optimistic, why I'm a bit pessimistic about other things, and I'm going to tell you need a personal plan. Okay, there is an increase in use of active learning methods. And if you look at the numbers, it's not a huge increase, but there is an increase. The other thing that happens is that the assistant professors are using active learning a lot more than full professors. The full professors like me are going to step out the door sometime. And so we're going to be left with people that are much more likely to use active learning techniques that work better than straight lecture. Secondly, there are a lot more courses available, workshops and certificates. For instance, a workshop that Rich Felder and Rebecca are going to give here next month. The potential of computers to improve engineering education, people have been talking about this for a long time, but the potential is actually starting to be met. And then there are national players, NSF and ABET, that can or could catalyze change. I don't know if they will, but they have the power to do it. Now, if you'd asked me 20 years ago or 10 years ago what the future would look like, I honestly thought I knew, and it turned out I did know. It was what you see is what you get. In other words, there were little pockets of people doing interesting educational research, but they were little pockets, and most of it was business as usual. Now, I'm not sure. It could be WYSIWYG, but maybe we'll get a paradigm shift, and maybe we're just going to get a smorgasbord of different things happening. Now, the paradigm shift, did it again. Okay, paradigm shift, I think it's going to happen. The only question is when. And it may take a long time. Okay, Mitch Daniels sent out an open letter. How many people have read Mitch Daniels' open letter? Well, shame on you that haven't. It's actually a good letter with lots of good information in there. He had a pretty good writer working with him. Well, I mean, you got to be honest. They dug up lots and lots of data, and there's no way Mitch Daniels had time to dig up all that data. But here's all the data that he had about some of the problems facing higher education. And some of these things are serious. That we went from 75% of Americans thinking a college degree was important to 44%. That's serious. So if you haven't read it, I suggest you read it. There are predictions of doom. Of course, they sell magazines too, so that actually is an interesting issue. Okay, here's where I see, and I'm not the only one, lots of other people see similar problems. If you take a massive online open system, and you don't even have to make it free, but if you can get 50,000 people in there, even though they are expensive to set up, the cost per student becomes very low. And currently, or the alternative is to have an interactive computer-aided instruction or tutorial system. Same thing, expensive to set up, you get lots and lots and lots of students taking it, and the cost per student becomes very inexpensive. Now, currently, if you have a mature student, they can go through this, learn what they need, go take a inexpensive $88 for 3 or 4 credits. CEB is the College Board. They've been doing this for years. Purdue accepts their test. You can go test out of calculus. You go take a MOOC, test out, learn the material, test out of calculus, costs you $88. It's a lot cheaper than 4 credits at Purdue. Now, if you're not mature, that doesn't work. So I said, other students. Other students is a euphemism for not mature. And they could sign up for a tutorial class that went with the MOOC. So the MOOC's the lectures, the tutorials, no lectures. Don't need a professor. All you need is an instructor. Master's degree, plenty, cheap. Who would do this? Purdue probably wouldn't want to do this, but the community colleges, private colleges would love to do this. They get pretty good students in there. And so you would take the test in class, which would handle the certification problem, and this will squeeze the non-prestigious institutions. Now, it doesn't do all aspects of college. I know that, but is the aspects of college like living in a dormitory and having the opportunity to meet people in other areas and to grow that way, do people think that's worth $10,000 to $50,000 a year? Lots of parents don't. Lots of students don't. Now, there's also parts of engineering education you can't do this way. But what's going to happen is our students are bright. They will figure out how to take advantage. Why not spend the first 2 years working like mad, studying on these things, and maybe you can do the first 2 years in a year and a half. I mean, because you can move at your own pace. And then come to school. And then you pick up all the labs, you pick up the design courses, and they're not going to want lecture. They're going to want something a little more active. It works. The minimum now for getting a Purdue degree is 32 credits at the 300 plus level. That's a year. And then you get a Purdue degree. Now, some of the engineering programs have other requirements on top of that, but that's the Purdue requirement. I came to Purdue as a transfer student. I see nothing wrong with this, okay? Now, other people may have troubles with it, but money-wise, it makes a lot of sense. Okay, here's the other paradigm shift. Suppose the federal government decided to cut research by 10%. That is going to cause enormous problems because a large amount of overhead and salary affects the entire university, not just the parts getting NSF and NIH money. And if that happens, suddenly there's a budget crisis. you don't even need 10%. All you got to do is have the Fed stop raising it for 2 or 3 years, and it caused problems. But they cause problems slower that way. What will happen again here is that the prestigious universities will do okay, because they do fine in the federal government, and if things get tighter, they still will do fine. And you squeeze the bottom. Okay, so the probability of this happening really quickly for the MOOCs, I don't think is real probable. I think what's going to happen is it's going to take a long time until you get to what's been called the tipping point. When suddenly people can see that this works and there's enough programs available that they can get what they need. And then it'll take off just because it's cheap. And the Ivy League is not going to be hurt. People still that can afford it are going to still want that education. I would not want to be at a school like, well, I'll pick on Indiana State. I would not want to be at Indiana State. I think a school that without a reputation will have trouble. So what do you do personally? Well, be a disruptor, not the disrupted. Get involved in the front end. That's one possibility. These things are expensive. So if you teach something too small, but important but too small for a MOOC, then you're probably safe. Become a professor at a prestigious institution, and in engineering, if you're a professor, you're already there. Become a research professor. But that doesn't work for paradigm shift number 2. That's the worst place to be if we get to shift number 2. Go to industry. Now, I have my own plans, and they don't fit any of these, okay? But my plan is to catch more fish. And I'm going to write the 4th edition of the book, publish a few more papers, and then in 2017 retire. So a few of you in the audience could use the same plan, but most of you can't, okay? Here I am with the fish. This is a 30-inch northern pike. Actually, that's a baby compared to the 41-inch one I caught last year, but I don't have a photo of it. And there's the canoe I built. I had time. I've been interested in these sort of things for a long time, but I never had time. And at that point, I'd be happy to take any questions or comments or brickbats and so forth.
You talked about MOOCs being a potential threat because it lets mature students absorb content on your own. And then you also talked about things about becoming an engineer that are not content, like a socialization and so forth. What proportion do you think those two things are in terms of, if you think becoming an engineer is 50% content, 50% not content, or 30-70, or?
Well, if you just look at the curriculum, the minimum required of any program at Purdue to become an engineer is, I think, probably 49 credits of engineering courses. You need 120 credits minimum to graduate with Purdue. So if I just take a ratio, I get what, roughly a third? I don't think you get socialized into becoming an engineer taking calculus courses. I think it's the engineering courses that do it. So if it is a third, 2 years is plenty. A year and a half is enough.
But it's not so much, here are the not engineering classes versus here are the engineering classes you have to take. If you lock someone in a room by themselves and they're smart and mature, and they memorize all the textbooks and could give correct answers to any math or physics problem you ask them, would they be an engineer, or would there be some kind of, yeah, you kind of have to hang out with other engineers and go to the machine shop and like the socialization, the knowledge contact.
Yeah, but again, I think that 2 years is enough. And particularly if you have somebody go on to grad school. We take people into grad school in engineering that don't have an undergraduate engineering degree. And when they walk out with their PhD, they at least sell themselves as engineers. And some of them are. Yes.
Going back to the original selling point of Purdue Engineers, going back to my year, before yours. The Purdue Engineers were noted as people who could come out of their 4 years of training and were ready to go to work. That was the reputation of the university, without very much additional training. And a lot of that, I think, had to do with the hands-on type experiences in the educational process. Now, we've eliminated a lot of those things, or they've been eliminated one way or another. How do you replace that if you're trying to keep your engineers known again as engineers who can come out of your educational institution ready to go to work, or as ready as you can be, and not teach them or put in much more of the hands-on things than we do now?
You have them build boats. I mean, seriously, you give them projects where, if possible, they build something. You put them in epics and so forth. You can substitute to some extent with the computer, but only to some extent.
So you were talking about someone who doesn't have a degree in engineering but a PhD in engineering. Some are actually engineers. Do you think the other way, people that study an undergrad in engineering but it's no longer working in engineering, are they still engineers?
Well, I talked to people who work in the pharmaceutical industry, and they say what they really liked was chemical engineers who got their bachelor's degree who went and got a PhD in chemistry, because they could play both sides of the game. And I think that if you take an engineer and move them, say, into management, they still have the analytical thinking process of engineers, which can be very capable. But they're not behaving as engineers, so it depends on what they think. Clearly, Neil Armstrong thought he was an engineer the whole way. A lot of people thought much higher of him.
What would you say to critics of your ideas that would ask, where's the rigor in educating this way? What response would you have for that?
Outcomes. If you measure outcomes, you can tell whether or not people have got it. And if you only look at inputs, you could claim, well, this isn't going to work. But I think that an ABET has gone outcomes. A lot of other accreditations, people have gone outcomes. Now, it's not going to work for everybody. But the current method doesn't work for everybody either.
So it's been really broad view of your career and impressive career. But now looking back, what would you say was the most exciting part of this career coming up? Number two, what was the least exciting, the worst? And writing proposals is not permitted as an answer for part two.
The worst semester was the semester I was interim associate dean. I mean, honestly, it was just not a job that fit me. Okay? Didn't mean I couldn't do it, but it just wore me out. The most exciting. You know, sometimes I get involved in research and it's really going good, and I like to do it myself, and I get really excited about it. And that research, while I'm doing it, is the best research I've done. And then, of course, I go on to do something else, and that's the best research I've done. And this is true of both technical and educational. So that excitement has reappeared at different times in my career, and that's when it gets really great.